Welcome to your sixth ACT video. So again, please set a timer for 8 minutes and then do these 7 questions. Once the timer goes off, then restart this video. So when we're trying to simplify complex fractions, basically what we're looking for is common denominators everywhere. Well, on top, the common denominator between x and 2, well, we need both 2x or 2 and x in there. So I'm going to multiply this by 2 and that by x. So that's going to give me 2 over 2x plus x over 2x. Then on the bottom, I need another x over here and 3 over 3 over here. So that's going to give me an x squared over 3x and 6 over 3x. So that's going to give me 2 plus x over 2x. Remember, you can just add the tops when you have common denominators. Then x squared plus 6 over 3x. And then when you're dividing, remember, you can multiply by the reciprocal. So multiplying by the reciprocal, you're going to have 2 plus x over 2x. And then you're going to be multiplying by, by 3x over x squared plus 6. So once you have all of that, now let's multiply everything together. So here, this 3x is going to distribute across the top. So you're going to have 6x plus 3x squared. And then this is going to distribute to there, and you're going to have 2x cubed plus 12x. So when all that smoke clears, you're going to get answer B. For number 24, what is the value of f of negative 1 for the linear function given in the table below? So we're being given that it is a linear function. So by being a linear function, we know that means it's going to be increasing or decreasing by the same amount for every term. So I'm going to focus on this part of my table right now. So if I know my y's are getting the same increase every time, I'm going to look here and see it increased by 3. So to be linear by definition, that means between every value in my table, I should be adding 3 to it. So what that means in the end is I'm going to take that negative 4, add 3 to it. That's going to leave me with negative 1. Number 25. So 25, we're dealing with composite functions. Remember, composite functions is when you take one function and completely put it in the other one. That's what this notation means. Now, in this case, you're evaluating a composite function. So remember, when you're evaluating a composite function, the best thing you can do is start on the inside and work outward. So I'm going to start on the inside. I'm going to evaluate what is g of 5. Well, when I calculate g of 5, 10 minus 1, I get 9. So if g of 5 is 9, really what I have is f of 9. That's what I actually want to calculate. So f of 9, so 3 times 9 squared plus 9. So 3 times 9 squared is 81 plus 9. When I do all of that, I end up getting 252, or that is going to be option E. For 26, Ainsley has 23 coins in her purse. If the total value of all her coins is $1.50 and she only has nickels and dimes, how many dimes does she have? So what I'm going to do is I'm going to recall that each of these is representing the number of dimes that she's holding. So I'm going to use the fact that this is a multiple choice question, and I'm going to work backwards. I'm going to start with letter C. So if she has 10 dimes, based on the fact she has 23 coins, that's telling me that she has 13 nickels. So if that one is correct, that would be the breakdown. Well, let's see what value that would have. She has 10 dimes, 13 nickels. If you calculate that, that's going to be $1.65. That's not the amount that we want, okay? That's not what we're looking for. So I know that letter C can't be right. I have too much money, okay? I had extra money than from what I wanted. So because I had too much money, let's go to another option, all right? Let's try another one that has less dimes. Because if I have less dimes, that means I'm not going to have as much money. She's not going to have enough or as much money in her purse. So let's try 7 dimes. Well, if she has 7 dimes, that means she's going to have 16 nickels in her purse. Let's calculate that. Let's see how much money she'd have now. When you calculate that out, you get the $1.50 that we were supposed to get. That is how much money is in her purse. So this type of problem becomes a lot easier if you end up working backwards from one of the answers. And now you know your answer is B. Which of these expressions is equivalent to that? So this is another common denominator question. In order to add or subtract these, we need a common denominator. So the easiest way to find a common denominator, well, see this x here? These are missing that x. See that x plus 4 here? Well, these are missing that x plus 4. So to find a common denominator, you have to give every denominator or every fraction the complete denominator that it's going to take. So now let's see what happens. So x times 3x is going to be 3x squared. My denominator is going to be x times x plus 4. The other one, I'm going to distribute that 4. So I'm going to have 4x plus 16. And then I'm going to have that same common denominator. That was the whole point of this, was to get that common denominator. And remember, once you have that common denominator, now you can just add across the top. Now, if you notice, in all of your answer choices, notice the bottom doesn't have any parentheses. So they don't want the bottom in factored form. They want you to distribute that x. So I'm going to have to rewrite this to say x times x is x squared, x times 4 is 4x. So that's how I finish the problem and get to answer choice C. So always make sure your answers look alike. Like my answer was correct, it just didn't look the way that they wanted it to. So I had to go back and reevaluate that I needed to distribute across the bottom as well. 28. So every ACT test that I've come across has had 1 or 2 questions about imaginary numbers. So you need to remember that I is equal to -1. Okay, it's a lot easier if you think and remember that. Now, the strategy, whenever you're multiplying 2 binomial things, the easiest method is to FOIL. 5 times 5 is 25. Minus 5i plus 5i minus I squared. Now notice these insides cancel, 5i minus 5i, so 25 minus I squared. Now notice it's not any of the answer choices, because I want you to think, if I know what I is, if I square both sides, that means I squared is equal to -1. So your 25 minus -1 is where I get 26. And that is going to be my answer. All right, and finally, 29. What is the missing term in the following geometric sequence? So here you need to remember what a geometric sequence is, what that means. A geometric sequence means you're multiplying to go from term to term to term. So we need to figure out what we're multiplying by. So that's the key here. I can use these two numbers. I need to figure out what do I multiply by to get from 48 to 192. Now, a quick way, if you divide, if you divide those two numbers, you get 4. So what that's telling me is I'm multiplying the 48 by 4 to get up to the 192. So that's just a quick, fast way. If you know that you're multiplying, we'll take a future term, divide it by the term before it. That'll tell you what you're multiplying by. So now that I know that, now I can multiply the 3 by 4 to get my answer of 12. All right, thank you so much for joining me for this video. Stay tuned for our next video during advisory.